Welcome at this video where I will treat vector analysis. We will discuss in the video how you can use the correlation matrix as a first step to vector analysis. We discuss some of the choices that you have to make before conducting an analysis. Is the number of vectors, the method of extraction, how you will extract these vectors, and whether you will rotate these vectors and how you will rotate them. Lastly, we will say something about the interpretation of the vector loadings and the vector scores. So vector analysis is an interdependence technique, meaning that none of the variables are either dependent or independent. All of the variables, vector analysis is really a method to address the intercorrelation between all the items. It is often used as to test the validity of multi-item scales, where you ask multiple questions to people in order to get a good feeling of a complex construct which has many different aspects. A last way to use vector analysis is data reduction, and this is often done in computer science or in many fields basically. Goal of vector analysis in testing the validity of the multi-item scales is to distinguish between the observed scores and the true score. Now, the true score is the score of someone on a scale. For instance, if I would have 3 items to measure a willingness to pay, I would say that the true score is the true willingness to pay of that particular person. However, what I do have are just his or her answers to the questions. There might be some measurement error related to the observed answers. Maybe the person was feeling very differently that day than normal, or maybe the questions were posed in such a manner that he or she responded very differently than she would have if the answer would asked a little bit different. So what is the procedure of conducting vector analysis? You first have to decide on the number of vectors. Now, you can do this a priori, meaning that beforehand you already have a gist of what it's going to be, how many vectors you will get. So, for instance, one multi-item scale to just measure willingness to pay is probably going to get 1 vector. But as we will see later on, there's also a scale measuring environmental concern, either from the community or the world. In that case, you would expect 2 vectors. A second way to decide on the number of vectors is the eigenvalues. The eigenvalues are calculated by SPSS. If they are larger than 1, by default, SPSS decides that these components or these vectors are substantially enough to explore them further. Another way to select the number of vectors is the explained variance of all the vectors that you extract together. So if you would extract 3 vectors, you would sum the explained variance of the first 3 vectors. For now, I go on with the method of extraction. So 2 of the main methods of extraction being mentioned in SPSS are principal component analysis, where you simply reduce the number of dimensions in the data, and principal access vectoring, which is principally used for uncover dimensions. Now, what is the difference? Well, actually, the difference is fairly small. With PCA, you use a correlation matrix, such as the one that you see here for 3 items, where the diagonals are 1s. If you use principal access vectoring, on the diagonal there are not 1s, but they are the number reduced by the measurement error. Therefore, the explained variance of the item. So basically, you correct for measurement error in the principal access vectoring method. Another choice you have to make is whether you will rotate the dimensions or not. So these vectors that you will estimate, they can either be orthogonal in the first picture, where they are rectangular to one another, or oblique, where they can be closer together as shown in the second figure. So the oblique rotation actually allows the two factors that you estimated using the factor analysis to be correlated. Now, in our example that I will give later, where you have 6 items, 3 items measuring the environmental concern towards the world, and the other 3 items measuring the environmental concern in the community, those two are probably related. If you would use a Varimax rotation technique, you would ignore this correlation between the 2 dimensions. So therefore, in most cases, I would propose to use the oblimin rotation to allow these factors to be correlated, which is usually the case. So I will give you one example of willingness to pay. 3 items that measure willingness to pay. As you can see here, there are 3 items. The last item is negatively correlated to the other 2 items. The highest correlation is between the first 2 items, and with the third item the correlation is considerably lower. So the next step will be to explore the factor analysis. We type in factor. We decide on, well, actually I just use the default criterion, which is the minimum eigenvalue, so I will not put criteria here. With the extraction, I will use puff to correct for measurement error. Rotation is not necessary because I will only extract one factor probably, or hopefully. So here I have the solution. So as you can see, the initial commonalities are not 1, which would be the case when using principal component analysis, but are smaller than 1. Now in here, the first eigenvalue is larger than 1, which is the default by SPSS, and that's why I only got 1 factor. But as you can see, also the explained variance is higher than 60%, which is often the case. Actually, the explained variance is related mathematically to the eigenvalues. So usually these two, if you have two factors which are higher than 1, you will probably also obtain the explained variance that is higher than 60% for 2 factors together. Now let's go look at the factor matrix. So here you see the factor loadings. What do they mean? It means that if someone would be more positive about giving the income for the environment, he or she will also get a higher score on this factor. You should regard the factor as an underlying dimension, as a variable, where people also can have scores on this variable. So you can see that the first item loads, we call this a factor loading, loads the highest on the factor compared to the other 2 items. So actually the first item is the most indicative of the factor compared to the other items. Now this last item has a negative factor loading. The more positive the response is towards this item, the more negative one scores on this factor. Now let's go to example 2 with environmental concern. This, as you remember correctly, there was the 2-dimensional construct where there is, on the one hand, the attitude towards the environment for the world, and the other one, on the other hand, the attitude towards the environment of the community. Again, I conduct the matrix. Well, as you can see, the first 3 items relate to the community. The last 3 items relate to problems in the world. As you can see in the correlation matrix, you already noticed that the first 3 items correlate more highly together than with the last three items. So here you have the very low correlations between the items of the world and the items of the community. However, the items of the world also correlate highly together. So here you can already see some of the two-dimensional structure. Now let's go to the factor analysis. In this case, as there are two constructs behind it, I will ask for two factors. Criteria factors 2. Rotation ugly mean, because I expect that the correlation between how people views the problems in the community relates to how we views the problems in the world. Now let's see, if we go to the eigenvalues in this table, you see that the first two are actually a lot larger than 1. After that they become a lot smaller. So also according to the other two rules, I would have selected two factors. The explained variance of two factors is 75%, and the first two factors have an eigenvalue larger than 1. Now, if we go to these matrices, we have to go to the pattern matrix, because this is the one where it is rotated. If we look at the factor loadings, we see that the first factor relates to the first three items. The other three items relate very weakly to the first factor. And for the second factor, the first three items relate very weakly, but the last three items relate highly to the second factor. So we could say that the first factor measures how someone views the environmental problems in the community, while the second factor measures how one views the environmental problems in the world. Now, in this last matrix, you can view how they are correlated. So what can this tell us about the validity of the scale? We have two concepts here that are vital importance: discriminative and convergent validity. The discriminative validity identifies whether the items really discriminate between the factors. When each item only loads highly on one factor, it means you have a high discriminant validity, since the items only are indicative of one factor. A convergent validity treats another a different topic, is whether the items of one scale that you already thought would belong to one scale really converge highly. So if all items measuring one concept load very highly on the same factor, then you have high convergent validity. Now, if you go back to our solution, we see that actually we have a high convergent validity of the first factor, since all the items load pretty strongly on the first factor, and also on the second factor. We also have a high discriminant validity, since all the items only have a high factor loading on one factor. This high discriminant and high convergent validity can already be observed in the correlation matrix. As you can see here, the first three items correlate highly among each other, and the second three items as well. This indicates the high convergent validity. Now, the low correlation between the first three set of items and the last set of items indicates a high discriminant validity. So you only observe 3 scores. From these 3 scores, you abstract one score that indicates the willingness to pay of this person. Now, if you use factor scores to indicate willingness to pay, you can view this as an underlying dimension at which every person has a score. So hopefully this will be normally distributed, with like low scores indicating a low willingness to pay and a high scores indicating a high willingness to pay.